Okay, in this next example, we're going to take a look at problem 4.21. And if you take a look, we have a beam with an offsetting arm here. It's 3.5 meters tall. This is shown with a break, so you don't have to draw it to scale. This is 400 millimeters over. It's got a load of 75 kilonewtons on this. And what they want us to do is replace the force at C by a force at A, right, and a couple, and B, a force at B and a couple. Okay, so I'm going to now take a short break to put this in the homework format on my sheet, and I recommend you do the same and follow through with the problem with me. All right, so I've set up the example using the homework format. It's 4.21. Given information, the diagram that's shown. You see down here, this is a column made of an I-beam, very likely. That's why the lines are here on the edge. And this is a arm extending out, probably done with an angle bracket. Again, that's why that piece is shown there. We have a force P over 400 millimeters from the center line AB, and this is shown with this break symbol because this is not drawn full to scale. So this will be 3.5 meters long. All right, so this is used as a drawing convention when you want to have when you have very long items that you don't want to show in full scale. In terms of what they want us to find, they want us to find the force at A and the moment, in this case the couple, and force at B and whatever the moment couple is going to be. Right? The book actually lists the question for A and C, but that's a typo. The fact is they're asking for A and B. We always assume these are rigid body, so we'll take a look at the solution. Solution is to go through and replace the force at A. So essentially, you're just going to move this force over. So FA is just going to be equal to 75 kilonewtons. Right? And in terms of the moments, right, we're doing our moments about point A, right, to determine what the couple is going to be equal to. And because we now move the force over there, so we now have a 75 kilonewton force. And so how would you go out doing this? Well, it's a vertical force. So in this case, it's 75 kilonewtons. And keep in mind, because it's a vertical force, we're really only looking for the horizontal distance. So we're not worried about this 3.5. So we're going to use our 400 millimeters. Lastly, when we take a look at this, it is going to cause a clockwise rotation, right? That's pushing up and over. So that is going to cause a clockwise rotation. And as we said from our sign convention, clockwise is positive. So in this case here, we're just going to multiply these two together. It's already positive. And when we do that, (400) times 75, right? We get 30 times 10 to the 3, right? So that's 30 times 10 to the 3. And that's already kilonewton, but millimeters. So probably easier to write this as instead 30 kilonewton meters. Right, so wipe out that millimeters by that 10 to the 3. Right, so so there's our answer. We have that's going to be equal to MC. So 4.1 part A, we have F sub A equals 75 kilonewtons, and the moment couple is going to be equal to 30 kilonewton meters. By the way, for part B, the fact is the force is unchanged. So FB is still going to be 75 kilonewtons. And by the way, again, the vertical position is not important. Because this is a vertical force, we're only worried about the horizontal distance. So it will turn out that the moment couple will still be 30 kilonewton meters. So that's unchanged. As always, if you have questions about any of the examples, feel free to get in touch with me and take advantage of the other examples and the other problems in the textbook and online to further your knowledge of this particular area.